Start with another topic of same quality quantitative techniques. We have almost completed six, 7 to 8 chapters. I think more than chapters. Now we have come with another new topic, which is time series and forecasting in the same quantitative technique. What exactly the time series for forecasting is what? It's a kind of prediction. We are doing the prediction for future. We are forecasting the things. So we will learn these things in the terms of mathematical terms, how we'll do the forecasting in the mathematical terms with the help of different data. So let's start with this. So time series forecasting. See, what is time series? We're going to learn component of time series, evaluation method, how to evaluate the forecasting. What I have told you, that we will get different kind of data from different sources. So how will evaluate that on those data to get the forecasting? Smoothing method of time series and time series decomposition. We will learn these things, all these things in this chapter. So what is time series? What exactly the time series? See, a time series is a collection of observation made sequential in a time. What we are getting the observation. We are getting the observation from the different sequential, from different sequential of time. You can see that over here we are getting the observation of here from different times, just like 0 second, 5 second, 100, 150, 200. This is the time series, and in the time series we are getting the observation. So a study or random sample of 4,000 graphics from 15 of the world's newspapers. From 15 of the world's newspaper published between 1974 to 1989 found that more than 75% of all graphics were time series. This is shown over here. Example, just like financial time series, scientific time series, these all the time series. What we can say that some financial data, when we are getting the financial data, we have to analyze, or we are doing some observation on that. So that is if it is rated to the financial, then it is a financial time series. If something which is we are getting in the scientific side, so it is a scientific time series. Time series models. Time series model is like regression model, deterministic model of a time. What is regression model, deterministic model, and stochastic models? So what is regression model? Regression model basically predicts the response over time of the variable under a study to change in one or more of the explanatory variables. See, variable will change when you're suppose you have one equation of the time, sub quadratic equation, x square plus y, x square plus 2x plus 3. When the time has been changed, the variable will be changed. Suppose there is a 2x and y axis. So when you plot this equation, suppose you have a single equation, x plus 2y plus z, x plus 2y plus 3. So you need to plot this x plus 2y plus 3 in a graph. I'm asking just an example. I told you in I think LPP, linear programming problem, how to plot the linear equation in a graph. So the same way you can plot the linear equation in a graph, and when the value of x and y will vary, the graph will vary accordingly. If suppose initially the value of x is 1 and value of y is 2, then you can plot the graph according to that. And when the value of x and y will change, you have to change your graph. So I mean to say the single line which come on the graph, it will vary from when the variable has been changed. The same thing it has told over here in the regression model. Deterministic model of a time series and a stochastic model of a time series. All the three kinds of model can be used for forecasting. These three models are used for forecasting. Basically, in most of the time for forecasting, we plot a graph, and with the help of graph we are doing our forecasting. We are getting some data for anything, just like if you are getting some data, something related to the financial, so you will get the data of the financial. Suppose I can say, I will give you the example, what happened in the stock market. You can see that you can take any stock, a single stock of any either commodity or any company stock, and you can see that it will vary When if the result of that particular company is very good, it will going up, and if the result is not as per the thinking of as per the requirement, then it will go down. So it will up and down. So according to that, we are forecasting after 4 months or 6 months what is the value of that particular stock, what the analysis are doing, what the analysis guys are doing. They are analyzing what they are doing, they are analyzing, they are forecasting of that particular stock in for the future. Then if they when they are analyzing, they are forecasting, then they are going to tell their customer that this stock is very good, you can take this stock for the future purpose. So this kind of scenario will come in the time series model. In the financial side, I can have given one example. Component of a time series. What is really the component of the time series? The pattern or behavior of the data in the time series has several components. Theoretically, any time series can be decomposed into, they are decomposed, scattered into trend, cyclical, seasonal, irregular. However, this component is often not straightforward because these factors interact. So any time series, whatever the time, either it is related to the financial, either it related to the financial side, financial or scientific side, they have a four component which shown over here: trend, cyclical, seasonal, or irregular. So these four kind of time series you can found over here: trend, cyclical, seasonal, or irregular. So trend component, what exactly the trend component? The trend component accounts for the gradual shifting of the time series to relatively higher or lower values over a long period of time. You can see over here, this is the time and this is the sale of any product. So it is going up and down, up and down, up and down. Obviously, if yours what happened, it is a real time of scenario. If you have any product, it is not every time that product will we give you the good response in the market while you're going to sell that product. Sometimes it will give you the very good response that it is a peak time, and sometimes it will not give you that much of good response what they have given initially starting. So it is going down, then might be again come again down, again come again down. This kind of scenario will create value or going to sell any product in the market. So this is the upward trend. You can see that here. If you see, this is the upward trend. Every time it is going to upward trend. So trend is usually the result of a long-term factors such as changes in the population, demographic, technology, or consumers. You can see that they have given trend is nothing but which what we are seeing our surrounding. Just like if you they have given you the example, population. It changes. Population is changes. Population in sense not related with only with the people are growing. Sometimes population is also related with their literacy and all. So each and everything we need to calculate regarding the in the population. Same demographic. If you see the demographic area, it changes. If you see any area nowadays, what happened? The area is not going. It is not scattered. It is going to narrow nowadays. Each and every area become narrow because of what the builders will do. They are planning the city and they are cutting the trees and all. So that's why the demographic area going to squeeze now. You can say it become narrowing. Then technology is also changing day to day. Initially we are using DOS operating system. Now we are using Windows 8, Windows 8.1 or 8.2 technology has come. Then consumer preferences. The consumer is also changing day to day. They are not stick with one product. A consumer which is using initially, I can say that any consumer, if they are using some product of HUL, might be they can move with the product of Procter and Gamble or some other products. So they are also changing their mind. So trend is changing. You can say that. This is not that any customer is stick with this product. Very few. Yes, there are, but they are very few. Nowadays, when the technology has changes, So mind of the consumer has also changes. Initially what we are using the mobile, so there is not any facility. We have only calling facility and messaging initially we are, you can start in the initial days when 90s, when we have a pager. With the help of pager we can sending of messages and all. Then cordless phone has come. Then after, in 2005 or 6, you can say the mobile era has come. After 2003 or 4, mobile era has come. Then initially the mobile is not with each and every person, but nowadays in 2014 or you can say 15, each and almost each and every person has a mobile, either a student or businessman or anyone, a rickshaw driver. Each and every person has a mobile in his hand. So the technology has changes, consumer mind has changes. So the consumer mind has changes because of the technology, because the technology has changes, so consumer want to change himself or herself. So these are things changes, this is a trend. Now next is seasonal component. Seasonal component accounts for regular pattern of variability within certain time periods, such as a year is also changes, such a certain time period. You can see over there something is going to up and something going to down in the seasonal wise. You can see there here quarterly, this is time is quarterly. Some product is going to I mean to say they have a good sales in some winter season, and it's down in spring, then again is go up into summer season, then again is going down in some other seasons. Like that they have shown over here. The variability does not always correspond with the season of the year, that is winter, spring and summer, fall. There can be an example within a week or within a day seasonal behavior. Yes, obviously. Sometimes suppose in a winter season we are wearing a sweater, so the sales of sweater become up, but it may or may not be possible in summer season. So sales of sweater has been up, but suddenly if the rain has started in the winter season, suppose for a week, for a 4 or 5 days heavy rain, then the umbrella is starting, I can say selling has started suddenly, because in the winter season suddenly the rain has come, so the umbrella selling of the umbrella is increases. So that is asked over here. Seasonal behavior, there can be, for example, within a week or within a day. You can see over here the seasonal behavior, how the atmosphere, how the climate has changed. So some product which depends on the climate, so it will their sales will be booming, their sales will be increased in the summer season. Some product which is sell in the winter season, their sales will be increased. Like that, this is shown over here. Then cyclical season, any regular pattern, it is a regular pattern, it will go up down up down up down, like that. It's a just kind of sine curve. Any regular pattern of sequence of values above and below the trend line lasting more than 1 year can be attributed to a cyclic component. More than 1 year, you can see over here. Usually this component is due to multi-year cyclic movement in the economy. Multi-year cyclic movement, you can understand the term multi-year. Might be this trend has to be in not for a single year, this trend has to be in multi-year movement, a cyclic movement in the economy. Some examples, if I give you the trend of I can say that calculation of GDP. Initially, see, when they have started the calculation of GDP, basically the GDP is like total number of population upon total number of what we earn, like that upon. So this is the way we can calculate somewhere in GDP. But initially from 1947 to till I can say 90s, they are using this similar to this kind of formula. So it's a cyclical same formula they are calculating for GDP. But suddenly in 90s they are thinking that now we have to change the formula and we have to follow some the method which is used in the Western country also though to calculate their GDP. So suddenly they have changed their formula to calculate GDP of the country. So this is a trend which is a cyclical trend for long term, but suddenly they have changed. Multi-year cyclical movement. Evaluation method of forecasting. What exactly is the evaluation method? Forecasting method is selected many times by intuition, previous experience or computer resources availability. I have told you that. So forecasting method is nothing but with the previous experience. Previous experience, intuition. What the intuition they have, what the previous experience they have, or the computer resources. Computer resources is nothing but the data. What the data they have availability. With the help of they are doing the forecasting of any method. Nothing but you have to think about the future. What I will get. So just I have given you the example of a stock. In the stock market, what they are working on, just like they are working on a single stock. Suppose the example I can say that suppose the product is HUL, Hindustan Unilever Limited, which is which is in there in stock exchange, which is listed in the stock exchange. HUL, Hindustan Unilever Limited. So HUL, what will it will do? So some person from the analyst side, some company analysis side, they are forecasting about the HUL because they have gone through from last for last 1 year. They have continuing chasing the performance of the HUL. So they have a lot of data related how the HUL goes up and how the HUL goes down in last 1 year, and their profit, their quarterly profit, their market, and how their product is doing a good or bad in the market. So all the data they will gather, and after that they will give their forecasting or their intuition that in the next coming months either this HUL will go up or down. So these things you can say this is nothing but a kind of forecasting or intuition. Divide the data into two sections, an initialization part and a test part. So what you can do, you can divide the data in two parts. One, you are initializing the data with the help of initialization, and another is the test part. So you are doing the testing on those data. Then use the forecast technique to determine the fitted values for the initialization data set. Use the forecasting technique. You are using the forecasting technique to determine the fitted value for the initialization data set. Then use the forecast technique to forecast the test data and determine the forecast above. Might be there some error has been come, so you are doing some forecasting technique, and then you are doing the testing on those data. Then evaluate error and use the technique, modify and develop the new model. Then you again, if you find some error, then you again start to modifying and developing a new model. Evaluation method for the forecast. There are three measures of accuracy to the fitted model: MAB, MAD and MSD for each of the sample forecasting and smoothing methods. These are the methods which have been used for the forecasting. All these measures, all the three measure the value of the value. The smaller the value, the better the fit in the. If the value is very small, it will very efficiently fit in the model. Use these statistics to compare the fit of the different methods. MAP, which is first model, mean absolute percentage error, which is mean absolute percentage error, which is called MAP. Measure the accuracy of fitted time series values. It expresses accuracy as a percentage. It expresses accuracy as a percentage. So MAP is equal to sigma yt minus y dash t yt dash yt minus yt dash upon yt upon n into 100, which is yt is not equal to 0. This is the formula. You can see that. So MAP, there is one method of evaluation or forecasting. Then second, now yt is the actual value or yt is a fitted value, and n is the number of observation, how we are going to observe. For each and every data we are doing the observation. MAD, second is mean absolute deviation. In everywhere, MAP, MAD and MSD. M is stand for mean. Here mean absolute deviation express accuracy is the same units of the data which help conceptualize the amount of error. It will conceptualize the amount of error. How it will show? MAD is equal to summation of yt minus y dash t upon n. This is MAD, summation of yt minus y dash t upon n, where yt is the actual value and yt dash is the fitted value. Same, n is the number of observation. The same yt and y dash t is the same what we have seen in the map. And third one is MSD, mean square deviation. Is a more sensitive measurement of usually large forecasting error than the MAD. Then where yt is the actual value and yt is the fitted value and n is the number of observation. That's it. Here MSD is equal to summation of yt minus yt dash t square upon n. So we have to square and we get the summation of that. Method of smoothing time series. What is the method of smoothing time series? Arithmetic moving average, exponentially smoothing methods, and hot winter method for exponential smoothing. Smoothing a time series to eliminate some of the short-term fluctuations. Smoothing also can be done to remove seasonal fluctuation, that is a deseasonalize a time series. What smoothing time series will do? It will eliminate the short term. There is a short term fluctuation will come while you are forecasting, and when you getting a data or you are about to forecast, then you will get some short term fluctuation. So you need to remove those fluctuations. Smoothing can also be done remove seasonal fluctuation. You can also remove the seasonal fluctuation, what we have seen in the two or three slide back. These models are deterministic in that no reference is made to the resources or nature of the underlying randomness in the series. The model involves extrapolation technique. So now averaging methods. Simple average, which is quick, inexpensive. We are going with simple average. Simple average in the sense number of values upon number of values upon number of those values. There is 5 values. We are getting the data just like 5 plus 6 plus 7, 1 plus 2 plus 3 plus 4 plus 5. So there is a 5 data, and those data 1, 2, 3, 4, 5, and we are divided by 5. 5 divided by 5, we are getting the average on those numbers. So moving average method consists of computing an average of the most recent n data values for the series, and using this average for forecasting the value of the time series for the next period. Moving average are useful. It's useful if one can assume item to be forecast will stay steady over time. Okay. Series of arithmetic means minus used only for smoothing provide overall impression of data over time. So this is moving average. Most recent and data times, what the data you have had, you have to add that upon n. What I have told you, just like 1, 2, 3, 4, 5 upon 5. Then moving average methods. It is work best in the with the data stationary data. The smaller the number, the more weight given the recent period. Smaller number is desirable when there are sudden shift in the level in the series. The greater the number, less weight is given more recent periods. The larger the order of the moving average, the greater the smoothing effect, larger n. When there are wide infrequent fluctuation in the data. By smoothing recent actual values, removes randomness. You can remove the randomness of the data. These are some methods. And then weight average method. Weight average method is nothing but a weight of the period and value of the period. We going to multiply this and summation of weight. That's it. This is the VMA, which is weight moving method, weight moving average method. Place more weight on the recent observation. Sum of the weight needs to equal to 1. So what you can do, you have to you have to do summation of the weight of the period end and the value of the period end. So, and then after that you are going to multiply both this. Notes on moving average. Moving average is nothing but MA. Models do not provide information about forecast confidence. We cannot calculate the standard errors. We cannot explain the stochastic component of the time series. This stochastic component creates the error in our forecast. They are creating some error while doing your forecasting. So exponential smoothing method, which single exponential smoothing and double exponential smoothing, and Holt method, which is called. Then third is Winter model. So note, single exponential smoothing is for series without train and without seasonal. So in the single exponential we don't have a train model and we don't have a seasonal component, what we have learned. In double exponential series with train and without, they have a train but not seasonal. In the winter we have a both train and seasonal. So in the single exponential we don't have anything. In the double exponential we have only train, no seasonal. But in the winter we have a both train and seasonal. So single exponential smoothing first. Continuing, revising the forecasting in light of more recent experience. Average smoothing past value of the series in a decreasing exponential manner. The observation are weighted with more weight being given to the more recent observation. Just like they have given example. So for single, AT is equal to AST time average sigma YT minus 1 minus sigma up to S1. The forecasting is equal to sigma into old observation plus 1 minus sigma into old forecast. So one is observation and old, for observation and forecasting we both need to multiply over here. So YT minus 1 is nothing but a old observation and AT minus 1 is nothing but a old forecast. Here we denote the original series by YT and the smoothing series by AT. The equation can be written as AT is equal to AT minus 1 plus alpha YT minus AT minus 1. Single exponential smoothing. When looking at the formula, new forecast is really the old forecast plus alpha times the error in the old forecast. This is the error alpha times. So to get started, we need to smoothing constant alpha and initial forecast and the actual value. We can use the first actual as a forecast value, or we can average the first and observation. We have to observe initially 8 to 10. So it has given you an observation, so you have to start with some observation. The smoothing constant serve as a weighting factor. When alpha is close to 1, a new forecast will include a subsequent adjustment to any error that occurred in the preceding forecast. When alpha is close to 0, the new forecast is very similar to the old forecast. So we have to observe what the value of alpha. If the alpha is close to 1, then it's a new forecast. If alpha is close to 0, so new forecast, what is they are getting is very familiar with the old course, very similar with the old forecast. So signal exponential smoothing. The smoothing constant alpha is an arbitrary choice, but generally falls between 0 to 0.5. So between 0 to 0.1 to 0.5. If we want to prediction to a stable and random variation smoothing, use the alpha. If you want to rapid response, then larger alpha. So we have to see what we are getting the value of alpha. Either we are getting a big value of alpha or we are getting a small value of alpha. On the basis of that, we are got to know that we are nearby the new value or old value. If it is 0, if it is 1, then it's a new value. If it is nearby 0, alpha is nearby 0, then it is old value, like that. So this is y exponential. Here they have given some formula, the same thing what we have learned, 80, 81, 80 minus 2 or 80 values. Alpha of the power k decrease exponentially. This is the sales data, single exponential smoothing. You can see that the small alpha here smooth the data. See, this is they are smoothing the data, how they are changing. They have shown over here the actual value. These are the actual values. Then it's smoothing. These are the smoothing. Then forecasting. We are doing the forecasting over here. Then the actual smoothing and forecast. This is shown over here. Here small alpha here smooth the data. So they have created the value. If the alpha is equal to 0.1, then MAP value, MAD value, and MSD value. This is they have they get with the help of the formula what we have seen. Then single data, single exponential smoothing. This is also the same thing. Here the smoothing and actual and smoothing is somewhere related to the same. So the value has been changed over here. When the alpha has changed, the value has been changed. The large alpha in the same example respond quickly to the data. Tracking, how we'll do tracking. Use the tracking signal measure of error over time. How will tracking in the sense we are tracking something, we are monitoring or we are tracking something to get if we are getting some error. So how to overcome with the error, how to overtime with the error, measure of error in a time to time, and setting limits. For example, if we forecast n periods, count the number of negative and positive error. If we are suppose forecasting some periods, so we have to count the number of negative and positive errors. If the number of positive errors is substantially less or greater than n by 2, then the process is out of control. We can also use 90% of prediction interval. If the forecast error is outside of the interval, use a new optimal, which is alpha. We use a new optimal, which is nothing but alpha. Looking back at the 0.1 single exponential smoothing, 1.96 square 24261 is equal to plus minus 305. Observation 21 is out of control. We need to re-evaluate alpha level because the technique is biased. Here they have given some example, and with the help of that we need to calculate the alpha. Exponential smoothing adjusted for trained Halt's method. Then trained Halt's method, what we have seen. In some situation, the observed data are trending and contain information that allows the anticipation of future upward movement. In this case, a linear trend forecast function is needed. Linear trend. In this case, we require a linear trend forecast. Method or function is needed. Halt smoothing method allow for evolving local linear trend in a time series and can be used to forecast. We are doing the forecasting, so we can do the forecasting with the help of this linear method. When there is a trend, an estimate of current slope and the current level is required. Current slope and current level is required, which we can see near in the graph. Halt method used two coefficients, which is alpha and beta. Alpha is the smoothing constant of the level, and beta is the trend smoothing constant. One is the smoothing constant, and the second one is trend smoothing constant, used to remove, which is basically used to remove the random error. Which it's going to remove from the beta. Advantage of Halt method: it provides a flexibility in the selecting of rates at which the level and trend are tracked. So it provides the flexibility to select the data, select rates in the sense data. You can select the data at which the level and trend are tracked, through which they can track your level and trend. So this is provide you the flexibility, nothing but a flexibility. Equation in Halt's method: the exponentially smoothing series on the current level estimate AT is equal to alpha yt plus 1 minus alpha at minus 1 plus t minus 1. So trend estimate t of t is equal to beta at minus 1 plus 1 minus beta into t minus. This is the formula of at. We are how we generate the S2 and S3. This is then the forecasting period in the future. And this they have given you what is the value of at, yt, tt, t minus yt plus p, y, alpha and beta. So this is the value, and you can put this value to get the answer. How to initiate Halt's method? To get started, initially value of a and t, which is required in equation S2 and S3, must be determined. So there is value of a and t which we need to get, then only we can go ahead. One approach is to set a1 and y1 and t1. Initially you can put a1, y1 and t1 equal to 0, so you will get some value of alpha and beta. The second approach is to use the average of the first 5 or 6 observation, as a1 and t1 is then estimate a1, and t1 is then estimated by the slope of the line that is fit into the 5 or 6 observation. So we have to take the observation initially 5 or 6 data, and with the help of that we will calculate the a1 and the slope of those, I can say that data 5 or 6 data. You can see that then the estimate that is a t1. Then Halt's method. Halt's method is smoothing with parameter alpha equal to 1 and beta equal to 0.19 for that electrical consumption. Winter method. Winter method is an easy way to account for seasonally when data have a seasonal. See, winter, you can see that it's with the help of name you can understand it is related with the seasonal. So it is a seasonal pattern. Winter method is nothing but a seasonal pattern. It extends Halt's method. It will extend the Halt's method. You can see that it will extend the Halt's method to include an estimate for seasonally. So it will do the work at seasonally. So it will do the estimation seasonally. Alpha is the smoothing constant for the label. Alpha, what is alpha? Initially we have seen it's a smoothing constant, and beta is the trend smoothing constant used to remove random errors. And gamma, here the gamma, alpha, beta and gamma has come, which is smoothing constant for seasonally. Because it's a winter method, is seasonally pattern, so we have taken the gamma also, which is the smoothing constant for seasonally. This formula removes seasonal effect. The forecast is modified by multiplying a seasonal index. So while we are doing the forecast, here we have to do the multiplying with the seasonal index. This is the winter method formula. The 4 equations used in the winter multiplication smoothing are A, which with the help of that we are calculating the method, which is AT, TT, ST and YT for a smoothing series or level estimate, then trend estimate, seasonal estimate and forecasting row period into the future. Winter method is also called triple exponential smoothing, and the value of AT, YT, TT the same as what we have seen in the previous. How to initiate winter method? To begin the winter method, the initial value for the smooth series AT and trend TT and the seasonal indicates ST must be set. One approach is to set the first estimate to AT and to Y1 and the trend to estimate to 0 and the seasonal indicates from 1. So it will show you the value of 0 and 1. Then we have a decomposition. How to decomposition? A procedure to identify the component factor in a time series. Component factor. Decomposition is give you the component, each and every component factor in the time series. How do components relate to the relate with the original series? Original series, a model that expresses the time series variable y in terms of the components T, C and S. I mean trend, cyclic and seasonal, and I for irregular. So additive components model and multiplicative components. We have a two kind of model, additive and multiplicative. Additive and multiplicative component model. It is difficult to deal with cyclic components. It is difficult to deal with cyclic components of a time series. To keep things simple, we assume that any cycle in the data is a part of trend. Any cycle in the data. It is difficult to deal with the cyclic component basically of a time series. So keep things simple. Assume that any cycle in a data is a part of trend. So additive component, this is YT, TT, ST and LT. Then multiplicative component, additive we have to add all these three, and in multiplicative model we have to multiply this. Additive and multiplicative models. So additive model works best when the time series has roughly same variability through the length of the series. That is, all the values in the series fall within a band with constant and centered on the trend. The multiplicative model works best when the variable of the time series increase with level. When it will increase with the level, then it will come. The multiplicating model has been worked. Otherwise, it will not. See the figure in the next slide. Most economic time series have seasonal variation that increase with the level of the series. So multiplicative model is suitable with them. Which economic time series which is seasonal, where the seasonal variable will come, then we have to apply for multiplicative models. Trend equation. There is some trend equation. Just like linear trend, we have for the linear trend we have a TT is equal to AT plus BT. So this is for linear trend, is a single linear equation. Trend can be described by a straight line or a smooth line. When it is a straight line, then obviously it's a single equation, linear equation. So it is linear equation. Here TT is a predictive value for the trend and of time T. The smooth T used for the variable represent time and takes integer value 1 up to 1 start. The slope B is a slope, is the average increase or decrease T for each period increase in time. Time trend equation can be fit to the data using the method of least square. This is the least square method, which is nothing but a YT minus T dash T square. Recall this equation. Select the value of coefficient in the trend equation, example B, so that the estimated trend T dash are close to actual value TT, and the measure by the sum of the square errors in the criteria. So additional trend curves. There is some additional trend curve which we will see over here. The life cycle of a new product has 3 stages. See, when you any product which is started, a new product, just like when the any product, you can say that when the anything has come, I can I give you the example. I can give you the example of which is now saturated. I can give you the example of simple. You can take example of any HUL product, just like they have a soap like Lux. Suppose initially when the Lux has come, it's a good growth. They have there is the advertisement is done by some big I can say that Bollywood celebrity. Then after that, when it will go up, when they have done the advertisement, so its growth become very high. So its sales become very high. So its growth become very high. Then it become mature. After some time, it become mature. Now it's become saturated. Sorry, now it becomes saturated. The curve is needed to model the trend over a new product. The simple function of allows for curvature is the quadratic tan. This is the quadratic equation, which is showing the quadratic tan over T square plus T square B2 plus T B1 B0 plus B1 T plus B2 T square. When the time series starts slowly and appears to be increasing at an increasing rate, which is nothing but exponential trend. So T dash is equal to B0 B1 T. The coefficient of B1 is related to the growth rate. B1 is related with the growth rate. This is, you can see the trend. the salespeople in a year. Initially in 91, for any product they have a very less salespeople. They have around for any product 13, 14. When the year has, my mentor say, in year by year, company hire a number of salespeople to sell their products, to advertise their product, to market their product. So now company basically focus mainly on the sales side. If the sales is they have launched some product, if the sales is not there, so there is no meaning to launch any product. So basically company launching a product to market that product, to advertise that product, to create a awareness about that product, they require a sales people, marketing people. So that's why nowadays company hiring more and more people in the sales or marketing or advertisement side. So the increase the number of sales people is not constant. It appears as if increasing large number of people are being added in the later year. An exponential trend curve fit to the sales people has data has the equation like this: T dash 10.016 into 1.331 T. They have taken over here the example. Then seasonally, several methods for measuring seasonal seasonal variations. What is the basic idea behind that? First, estimate and remove the trend from the original series, and then smooth out the irregular component. First, estimate and remove the trend from the original series, and then smooth out an irregular component. This leaves data containing only seasonal variables. This actually leaves the data which contains only seasonal variables. The seasonal values are collected and summarized to produce a number of each observation interval of a year. So seasonal variable you will get in a week time, in a day time, in a quarterly or monthly or yearly, so on, whatever the way you want. Identification of a seasonal component. The identification of a seasonal component in a time series differ from trend analysis in two ways. Number one, the trend is determined directly from the original data, but the seasonal component determined directly after eliminating the other component. We are eliminating the other component from the data, then only we will get the seasonal components. The trend is represented by one best fitting curve, but the separate seasonal value is computed for each observation interval. If an additive decomposition is employed, estimate of the trend, seasonal components are added together to produce the original series. Seasonal component, what they are doing? Added together. They are adding together to produce the original series. If a multiplicating component is employed, if a multiplicating decomposition is employed, estimate of individual components must be multiplied together to produce the original series. Seasonal indices. The seasonal indices measure the seasonal variation in the series. Seasonal indices are percentage that show changes over time, for any product. Example, with monthly data, a seasonal index of 1 of a particular monthly means the expected value for the month is 1 upon 12, the total number of years. For monthly, we have to divide by 12. An index of 1.25 of a different month implies the observation for that month is expected to be 25% more than 1 by 12 of the total month, annual total, sorry. The monthly index of 0.80 indicates that the expected level of the month is 20%, which is less than 1 by 12, the total for the year. Then seasonal adjustment. After a seasonal component has been isolated, it can be used to calculate seasonally adjusted data. Seasonally adjustment technique are ad hoc technique method of computing seasonal indices, and use those indices of deseasonalize the series by removing those season variation. For multiplicative decomposition, the seasonally adjustment data computed by dividing the original data by the seasonal components, which is shown over here. So seasonal data is equal to raw data upon seasonal index. This is nothing but a seasonal index, so we have divided the data with the seasonal index. This is seasonal adjustment technique. In the first technique, we can see that seasonal time, which is time series, we can see there multiply with T, S, C, and I, the 4 products. And in the second one, it will showing the YTMD computed is equal to the series over here and divided by 12. This is all monthly. For monthly, we have to divide by 12. This is the same seasonal adjustment technique where they have S into L multiplied by S and I multiplied, which is equal to YT upon YMT, and which is nothing but a ZT. This is showing over here. So this is all how we calculate the seasonal components. And the same thing we can see over here how we calculate the seasonal thing, but this is not related with your, I have seen your books, but this is not there, so that's why I have just put over here, but it's not related. So now least square parameter parameter estimate, how we'll do this. We can see here equation equating this derivative to 0 and dividing by 2, we will get these things. This is all formula. This is all formula, but this is not related with you, but I have put over there to just understand, but I realize that this is not related with our course, so I can eliminate this. So now we have completed the time series and forecasting. So time series and forecasting has basically we have learned about how we do the forecasting with the help of mathematical terms, and we are doing the forecasting, how we calculate the time series, and these things we have understand little bit regarding with the help of time series and all. So here we have to understand only the main thing which come in the exam might be they will come about the time series and component of time series and evaluation method. Don't go in the formula because it will little bit difficult, but yeah, you can understand about the time, what is the time series, how we'll do the forecasting in the time series. Initially side what I have shown you over here. So initially side, this what is exactly the time series, how it will vary with, just like I have given you an example of sales data, so you can give the example anything which come in your mind. So how it is vary with the help of time series, I have given you some example over here with example financial time series, scientific time series. So you can think about yourself and you can come with some new example, come with some own examples, and you can share. And then we have some time series model with what I have told you, regression model, deterministic model, and stochastic model. And we have learned about how the time series component, the 4 component, trend, cyclical, seasonal, and irregular. Just keep in your mind what is trend, what is cyclical, what is seasonal, what is irregular. So we have shown you the trend, how I have given an example of trend, which is nothing but some example related to the sales data, how it is going up and down, see example of population, what I have shown you. So population sometimes go up and down, not in the population sense, just think about we can include the literacy, number of people there is in the population, number of men, number of women is there, number of old people are there, number of young people are there. Just like India is now become it's called a country of youth, because there is a lot of youth now. So in our population around more than 40% population are youth, and apart from that in the 40 to 60 apart from 60% population, there is old population, and there is a population which is beyond 40 of age. So these trends are there. Then demographic, what I have told you about demographic. In the demographic, we have to think about how the area has changed. Now the demographic area become narrow and all. Then we have seen the example of technology. In the technology, what I can say that in how the technology is changing day to day. Initially in 90s, what we are using in the pager and we are using DOS prompt. Now we can see that in the today we are seeing the we are working on the Windows 8 and Windows 8.1, and now in the mobile and page at that time. Now we can see the mobile, and there is lot of things has been added. So technology is changing day by day. So it is showing the trends of technology, how it is changing. Then consumer mind has been changing. Was the consumer is thinking in 90s or 90s or mid 90s, that have been changed. The consumer is changing because of the technology. So technology impact on the consumer mind. So it has trained become, so now it become trained to change there. So then we have talk about the seasonal component, how the seasonal components are vary. So in the winter, suppose I have given an example of sweater, a sweater which is nothing but when the winter has come, so shawl and sweater has then the increase the number of consumer of shawl and sweater. They want some warm clothes. So sales of warm clothes have become attire become more and more. And in the summer season, you can see that the sale of AC, air conditioner or cooler has been increased because of the hot season. Consumer required more and more air conditioner, or I can say the cooler. So the increase the number of sales of that those things. And again here in the winter, and you can see that sometimes what happened in the winter, I have told you, so suddenly I can say that rain has started for a few days or week. So then the same season, apart from selling of the warm attire or clothes, the sale of umbrella has been increased. So like this trend you can see over here within a week, within a day. There can be, for example, within a week or within a day, seasonal behavior. So it's behaving different. Then cyclic component, what I have shown you, the economic, how the economic has changed. I have given an example of GDP. We are calculating something different, and now we are using some different formula. So this is a cycling component over here. So an irregular pattern of sequence of value above and below the trend, last casting, line casting more than 1 year can be attributed to the cyclic component. This is the cyclic. Usually this component is due to multi-year cyclic movements in the economy. These are the, we have seen cyclic, seasonal, trend. So these are the components what we have seen over here. So these things you have to keep in your mind. So these things you have to keep in mind. So basically these things will ask you in the examination. They will not ask you to write any formula for that, how to calculate the time series and how to do how to calculate this and that. Basically whatever we have learned over here, so we have to relate these things in the real time example. Just I have given what I would do, what I'm going to do when I'm going to take anything. Just like I have taken example of trend or cyclical or seasonal theories. So I have given you the example of real world, what exactly the trend in the real world is going on, how we'll get the example of trend to the real world. The same thing, I have given you an example of cyclical theory in the real world. So the same way you have to think about how we can do the same thing with the real world. My mentor said, how will I can give you the example, not for this, for each and every, I can say that course or each and every subject, you have to think in the real world. Because in the we are not we are the manager, and we don't want, we are not to think the narrow mind. We are not broad. We have to think broad.